So yeah, I'm just gonna say a little bit about why we made this thing together. So Surya has been interested in packets for a while, and we sort of crossed paths when I was first learning about radio and Wi-Fi and packets, partly in your class. And yeah, I said this a little bit a couple days ago, but something I love about packets is that they're this very like contained snapshot and an access point to talk about like the larger system that is the internet. And also, you know, we both were talking about how there are not like technical resources for learning about the internet that are geared towards folks who are not, you know, training to be a network analyst or something. Yeah, Wireshark. So, are folks familiar with this program, Wireshark? No?
Show of hands, how many people have heard of it?
Yeah. So I'm curious. What were your first feelings?
I'll explain what it is first.
Oh yeah, sure. So this is a packet analysis program for sort of network engineers that helps people troubleshoot things that are happening on their network. But it's also currently one of the ways that, you know, I was learning about packets and I was trying to learn about networks. And when you start this program and you hit go, you just get this like a really overwhelming stream of that
garbage. It just looks like total garbage. It's like, this is the internet, great.
Yeah.
But what does that mean? All these colors. You could be at a rave, but it's like very pastely rave.
Yeah, you could just screen this in the background.
Right.
But you know, as we were having conversations about what it would look like to do something like this in a way that was more accessible and approachable for people who don't want to, you know, dig into each level of this, and you don't want to look at every single byte of every single packet for whatever reason, we sort of came up with this project Herbivore.
And I think the main goal behind this project is actually to is to kind of like talk, and we'll go through it now, but like is to talk about the sort of the aspect of computers talking to each other in a broader context. I think that's something that's really nice about all the talks I've kind of heard over here. There's like a nice like marriage of like the technology, but like who owns the technology and why does the protocol operate the way it does, and who are the actual humans and organizations behind it. And a big goal behind Herbivore is to not be like the de facto packet sniffer that does everything, but it's more to be able to kind of focus in on a particular set of like exploration, so we can really start understanding how like what power looks like in a network system, or like what like commerce actually like looks like or like smells like, you know. I always think of this analogy of like having it be more intuitive than like cognitive. So you should be able to feel, and I think like a lot of people who spend time on computers for a very long time have like a more intuitive sense of like, this site feels dodgy or this thing feels wrong, or that like that's something you build over many years. But as technology's kind of progressed, everything's gotten shinier and it's sort of harder to have that same intuition. So we tend to find ways to kind of go dig deep and let people like kind of investigate for themselves. So you're not.
Yeah. So this is all sort of very high level, and cool. Yeah. Before we sort of dig into what packet sniffing, what we're actually doing with Herbivore, we thought it would be helpful to do this really short activity where Surya is passing out cards with different pieces of internet infrastructure. So there's a card with ISP, internet service provider. There's a card with a router on it, a card with a server on it, and if folks could like break out into groups of 4 or 5 and sort of lay out how you think a website actually gets to your computer. Like when you sit in front of this thing, how do you, and you open your browser, how does all this stuff actually get to your eyes? And then we'll sort of come back together and share out. And these cards are by Tactical Tech, which is based out of Berlin, and they're available online if you want to, use these in your own sort of teaching context. Yeah. So we'll just take like 5 minutes, 5 or 10 minutes to do that.
Sorry, yes.
You want somebody?
I mean, no, I think my friend just don't use the doubles.
Wait, is it? ISP? Yeah, well, I don't know. No, we shouldn't Google.
I mean, depends which side you want it on. The website also looks nice.
Did I miss one?
Internet service provider. I'll just give you some. We like so fast. We just put out all like cards.
You have doubles.
Yeah.
We like extenders.
Oh, we have doubles?
Why does router extenders? You don't have, yeah, you should put extenders in.
Wait, I think it's that. Let's see.
Where is the Wi-Fi extender? I'm gonna write this thing.
There's this other option here.
Oh man.
So we discussed
Take out
this exercise.
No, never.
Wait, so the website? Oh, the server? Yeah. Is the computer? But I don't know. But they have computer Wi-Fi. Wait, we have that.
Started that.
Yeah, you need the
Wi-Fi website.
Oh yeah, you're right. You're right.
So, wait, but there's computers everywhere, right? There's computers in all of these levels.
We need more computers, just so you know. And we need Wi-Fi extenders.
It's already doing it.
It's like,
Oh, thank you. Couple minutes.
Wait.
I don't think I know how to turn it works.
yeah, right? I have a book.
On a computer. But the router connects. I don't know. This is the trick question, I think. Kind of, yeah.
I mean, I guess it's all
Wait, is there no card that says the internet?
Cloud.
Check.
Yeah.
The cloud.
Who's wearing my last
Yeah, and it's not being requested.
Yes.
Or maybe part of it.
Very.
Really?
So do folks, you have your internet sort of laid out? Is there a group that would be willing to walk us through what you made, what you built? All the pieces sort of work?
You guys understood?
Yeah.
We got a server over here, connected to this ISP. It's connected to this router. This router isn't a home router. This router is connecting these
Oh my
two
God.
ISPs. And the ISP is connected to this router, which is a home router, which is broadcasting some Wi-Fi to this website on this client's computer. Also, is running his own homebrew server.
Oh my god.
I asked the wrong group. But I mean, I think if you all have these cards, you should kind of get this flow of like computer, Wi-Fi, router, ISP, server, right? So like those are like, I mean, when you go to a website, the actual like cables or wireless thing where the highway the packet is going through, those are your main sort of components. And I think it's fair to say that that's always true. So if you're going to hit a server that's on the internet, be it from your phone, from your home network, some version of this will happen each time. If it's your phone, it might be a cell tower instead of a router. But the principle for like that packet transmission tends to be, especially if you think of it at an organizational level, where like you'll have your device, then you'll have a telecommunications network in the middle, and then you'll have like a website hosting company and this actual service. You know what I mean? Like so, they're like those are the different components I think are flat.
Yeah. So, yeah, I mean, I think you explained what each of the pieces sort of is. And just to drill down into this sort of unit that we're really working with here, which is kind of the website, which you know, we've been talking about packets and how packets are flowing in this sort of path, but what we're actually talking about is when we look at a website on our computer, a website is just a bunch of files, right? And all of the files are getting to us broken up into chunks of information. So if we go to a website that has photos, you know, we're getting the photos, we're getting the styling, we're getting the body, and all of this stuff is broken up into packets of information that's sent along this network. And in order for these packets to sort of get to where they're going, there's a lot of addressing involved. There are like many different levels of addresses. And so that's sort of the framing for what we're gonna drill into with Herbivore.
Right, and I think like that's like the most important part of packet sniffing is really understanding the addressing system and trying to figure out where this packet is coming and going from and where you are in relationship to that directionality. So I'm just bringing this up because of how I like to think about it, or what Jen just described is like if you think of that as a cat GIF, that cat GIF actually comes to a computer in all these little components, and each one of these jigsaw puzzle pieces is a packet. Right, so when we're packet sniffing, you're actually picking up like chunks of these images or whatever the like websites or whatever the data is. So you're never going to see a fully constructed thing because as it comes through the network, it's actually coming broken up. Does that make sense? Does anyone have questions at this point?
Yeah.
Cool.
And just to add that like each of these puzzle pieces has, we'll dig into the headers, but there's, you know, it says the address that it's coming from, the address that it's going to, there's a timestamp, sometimes there's location information, and this is for like every single piece of the puzzle, for every piece of data that is, you know, transmitted across any network. That's a lot of information.
Yeah, and I think like the reason we're going to dig into this stuff is to kind of like help build this context that unlike a lot of other technical literacy with networking, you really don't need to know how to code. You're kind of what you need to be better at is like being like a good receptionist, where you have like a sense of your building, what comes and goes from it, who are all the players in it. So when you see a packet, you're rarely writing any lines of code. You're just looking at information coming through, and based on what you're seeing in each packet, you're trying to infer information from it. So and you'll see as you go through Herbivore that we're not actually going to do much like anything technical. We're just going to click a bunch of buttons, but there's a lot of information on display that we can use to investigate the system further. So with that, I would request those of you who are here on a Mac to go to this website to download Herbivore. Has anyone here downloaded it already? No, great. Okay, so those who have can wait, but those who haven't, just go to Herbivore, and then there's a download release link on it. Unfortunately, currently it's only Mac because I'm lazy, but it'll become other things soon also. But yeah, if you go to download release, there's a Radical Networks release, and that'll just download a zip file. And for those who don't have a Mac, just share with the people around, like let people just share so that everyone can see the screen. And once you've done that, open it up and you should see something like this, and just let me know when everyone is at this part. I guess I'll also open it. Oh no, I should. I'm louder than you, so you should.
Okay.
Is the Mac only situation because the release is just a Mac build, or is it something in the source that?
It's so dumb, but like I have an ARP like an ARP package which someone hasn't done Windows for yet, so it breaks. Yeah. So it's just like it's just and it's more than that. I just haven't had a chance to test it on a bunch of other devices, so I haven't wanted to say it does things. It doesn't yet. But if you guys download it and like play with it, I'm sure you could get it up and running. It's not far from running. All right. So is everyone at this stage? Do you have some version? Who doesn't have this on their screen right now? All right, okay, that's fine. For those that do, just go to the permissions tab on top. We need to set a few permissions at the start to allow Herbivore to read all the network packets. It's not doing anything creepy. It's just like allowing read access to your network card. So go to set, and you're going to have to type in your password 3 times because again, I'm lazy. So I'm putting the work on you guys. All of these things will be fixed eventually, but for now, just like type it in 3 times, and that'll just like set the permissions on your network card. If I'm going too fast, just raise your hand and I'll slow down. If anyone has questions, just let me know and we can slow down. Everyone good? Yep. All right, so I'm going to go to so let's get started then. And the first thing we're going to do is we're going to go back to our, the map you have in front of you with the little pieces and think about where we are in this network, right? So you have your computer, you have a router, you have an ISP, and then you have a server, right? Everyone has that sort of like laid out in front of them, I think. And what we're looking at in this view right now is basically what's happening. The first thing that I think it's important to talk about when thinking about packet sniffing or networks in general is the difference between your private local network and the public internet and what that actually means. So if you look at this orange tab on top, you should all have the number of devices you see on the network, a host name for your computer if you have one, the private IP. This is the IP address you have on the Radical Networks network, and then a public IP. And the public IP is what the internet sees all of Radical Networks as, right? So like going back to that analogy of like the computer, router, ISP, server, when you send a packet from your computer to your router, you're addressed as this local IP address. Does everyone see this on their screens? So that's your local sort of like ID on that network. But when that request is going beyond your local network to the actual internet, the internet sees you as 108.27. So I think everyone here should have the same public IP address. Is that accurate? Mm-hmm. Right. So that means that even though within this local network we have different addresses to the world, we all look the same. An analogy that I think of with that is like in a building, where for the postal service you have like one building address, but then you have like different apartments within it. But the postal service only cares about getting it to you pretty much to the building, and then like whatever the slot is for that thing is kind of handled by the building side. Similarly, there's a private IP, public IP distinction. Right, so that's the first step. But the other thing, so like I kind of like jamming off your talk from yesterday, what Herbivore really is trying to do is sort of be like the developer tools that browsers have, but for your local network. So what it's trying to do is let you be able to inspect what's happening at the route. So in that chart again of like computer, router, blah, 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 we're really paying attention to what's happening either on your computer or on your local network. So what we're seeing in this crazy graph right now is that there's 69 devices on this network. The router has this address of 192.168.1.1, and these are all the other devices underneath it. And I'm just going to now go through these different columns. So this column on the left is called your MAC address. The MAC address is actually a really important thing to know about if you're doing networking. It's basically the unique address your hard. So this goes back to Jen's point of like why addressing is important when you're thinking about network systems, because there are many different types of addresses. So IP addresses are something that a router gives computers when they join the network. So it's sort of like a if you go to like an office building and they give you like a visitor's pass, it's like that. It's like every time you do it, it's a new transaction, you get a new card. It might be the same one, it might be a different one. But your MAC address is like a driver's license. That is unique to you, or your social security number. That is unique to you no matter where you go. So when people are trying to identify devices on a network, IP addresses give you some inclination, but MAC addresses are actually like kind of like hard coded into the hardware. So changing it is not trivial. So the point of saying all of this is that like my computer, which has a MAC address of D7.
Let's write it down.
You don't need to write it down, but this, when you do this long enough, you'll memorize it. But like that, so that never changes. So no matter what network I go to, if I like kind of do a scan of the network, I will always see this MAC address if I'm using this computer. But that MAC address might have a different IP address, right? And the other kind of interesting thing about, so again, going back to this idea of thinking about addressing and how much information we can get out of these systems. Once you know a device's MAC address, the first three bytes of this MAC address are actually unique for each company. So you can use something called an OUI lookup, which I forget what OUI stands for. But basically, if I search 48D705 in here, and do search, it'll say down there that it belongs to Apple. Just make that bigger. Can you see that? So it says that that MAC address is registered to Apple. So that basically means that when I do a scan on this network and get every MAC address, I also by default know all the manufacturers of devices, right? So I can tell on this network, for example, we have a bunch of Apple devices. You can start getting some host names. So I can see like Chemistry's MacBook Pro, Keep It Weird Cat, great. That's a great name. So a lot of Apple devices. Chase's MacBook Air, I don't know Chase's, but probably here somewhere. HTC, so that's probably a phone. Hewlett Packard, so that's either, I don't know what that is. That's normally a printer. Intel, that's probably like a Chromebook or a Dynabook, interesting. Live stream, so there's like, we have some like network cameras around here. Ubiquiti is the routers, I believe. So just by seeing this information, I've already kind of understood. All right, I'm probably not on a home network right now. I'm in some place that there are like 69 people. There's a bunch of different routers for the same network. There's like a live stream camera. There's a couple of printers, and a bunch of different computers. Yeah.
Is there a reason why the number is different? Like online, I can see 46 devices.
Oh, that's weird. Sometimes you can be on a different subnet, but like, yeah, there might be some like weirdness with the network, but usually you should see the same. What could happen is if the devices are asleep, I might have seen them when they were so active, but now they're no longer on the network.
Can you refresh?
You have to like restart the app. It's stupid. But yeah, so
We're writing you a design feedback.
great, thank you. I appreciate it. So yeah, so that's kind of like, I would say, the baseline. So just to kind of hone that point in, we're really only paying attention to two sets of numbers, MAC addresses and IP addresses. But just with those two things, we can get a lot of information, right? So for MAC addresses, I can use this OUI lookup tool to figure out what vendor that device belongs to. And with IP addresses, I can actually figure out who they belong to using a tool called Whois, which I think, has anyone here heard of Whois before, right? So just for context, like if I take this number, this 108.27.217.191, and do a Whois lookup on it, I can see that these guys probably have Verizon as they probably have Fios in this building. Right, so like I can tell that this IP address belongs to MCI Communication Services, DBA Verizon. So just by looking at that IP address, does that make sense what I'm showing? Does everyone, I see some like unclear faces?
Was that the local IP address or the public?
The public IP address. So that's the public IP address. So that's what, to the world, every packet that's going out from this network is first going through a Verizon ISP. Right? And that's something that we don't really think about when we're thinking about connecting to the internet, that there's always this first step, and that's the ISP you're kind of hitting. Cool, so that's all I want to say about the networks tab. Now Jan's going to talk about the packets tab.
Cool.
You want to swap?
Yeah.
Yeah.
The public IP, is that unique to just the network or to my computer?
That's unique to the network. So every computer on this network, when it sends a packet outside of this network, it goes with that IP address.
So don't I have like one unique IP to the world?
That's the public IP.
But everyone has that same IP?
Yes. Because to the world, we're all one IP.
So
Is
there's
it-
no like look up one specific IP for one specific computer in the world.
Nope. Because to the world, you all look the same. It's great.
But that would be your MAC address, right? Like your
Yes.
your ID would be your.
Your Mac, but you wouldn't be able to look
Right.
at that outside the local network.
How do I?
Any other questions at this point?
On the host name, how come some of them have a host name and others don't?
Because some devices no longer. So this is kind of part of the computer security thing that's been happening over the years. That now devices don't just give this info. Because the way we're getting all this information is we're readily. Herbivore is just asking it off the network. It's not doing anything nefarious. It's just saying, hey, can everyone tell me that who's here? Can you just tell me? And if your device doesn't want to tell me, then I don't know.
But like, so some of these Apple ones have it. Like I know my computer has a name. How come
Right.
it doesn't show up here?
Because you probably are in a newer OS, and by default, Apple doesn't show host names anymore. So iPhones no longer, for example, broadcast their host name. So that's like a bonjour lookup. It's a DNS thing.
I guess if you have like 0 host names here.
I think that's probably just because of like when the scan happened. But if you have 0 host names, it's just because you didn't get any of the devices that had some. I can look at it with you later. Yeah, I'm not sure why it's happening. Because also when there's like multiple routers, there could be different subnets, so we might not get the same devices.
Yep. And just one more thing on this is just that this is also a very common thing for there to be this sort of, not human readable address, this MAC address that also corresponds to one, like a human readable version. And there, that is for MAC addresses, that happens for IP addresses, that happens for lots of different kinds of addressing in networks. Cool, so now there's one other view in Herbivore, which is the packet view. So we are just going to sniff our own traffic
Right.
here.
So you should click on the row which has U on it in the networks view. Does everyone see that? And then Herbivore will basically intercept the traffic from your computer.
So just double click that. Or single click. Any number of clicks works. And okay, so this is the packet view. So this is where, we'll see information coming from the source IP. So this is this computer. I mean, the source IP isn't always this computer, but we know our IP address, right? And so we can see that, this packet starts from this computer and goes to this IP address. Whereas probably when we go to websites and we start getting stuff back, we'll see our IP address in the destination spot. So let's do that. Close.
What if you don't see anything?
We might not be sending any traffic, so try going to like a web page.
No, it's not.
Okay, yeah, because you have a VPN, it won't come up.
So we'll go to Surya's website because it's HTTP, it's not encrypted. And so we'll be able to look at some of the packets that come in. So, yeah.
Did you set the permissions at the start? Okay.
And are you getting stuff?
If anyone's having trouble, just raise your hand and I can come around and look, yeah.
Oh. Are folks, when you go to Surya's website, are you able to look at some packets that are coming in?
Wait, can you explain the difference between the private and what's the private IP again? It's
So the private IP is the address that your computer is assigned by the router.
okay, I see. So
It's a floating IP. like it changes every time?
It'll change if you connect to a different router.
Right, okay.
Yeah.
Online.
So these numbers are quite standard, right? Like the IP, like that's what it looks
Yeah,
like. It's
so it'll
pretty
be,
standard, right?
yeah, it'll be a set of, a quartet of 3 up to, and it can be up to 255 for each of these sort of chunks.
Okay.
So
And it's just random.
255.255.255.255,
Right. Okay.
yeah. There'll be something in there.
It's like RGB.
Yeah, which is related to bytes. I don't totally
Yeah,
understand
that's
that
true,
part,
that's
but
true,
it's 255 is a recurring
It
number
is,
in computing.
Yeah, totally.
So yeah, you'll see, if you get a packet with this lock under content type, that's because that packet was sent via HTTPS and we can't actually look inside of it, but we still get metadata about it. So we can still see, the host that you were trying to access. We can see, the port numbers that were involved. We can see the IP addresses, even if we can't see the content itself. So, and we'll look at some interesting examples of where that becomes interesting is when, you're sniffing your phone, for example, and you're opening apps, and your phone is making requests to websites that you're not explicitly making requests to, but you can see that packets are coming in from weird places, weird host names, and even if you can't see the content, you know that some application on your phone, like Snapchat, is sending and asking for data of some third party. And we'll actually walk through that. Anyway, okay. Yes.
So sorry, so when you say sniffing your phone, so then your phone would be connected to the same Wi-Fi network
Yes.
that your computer is.
Yes.
You would recognize it. Okay.
Yeah, so in that case, and yeah, I sort of jumped ahead, but in that case, you would see your phone's IP address in this network table, and you could sniff it, and you could, look at your phone's network traffic, which can be really interesting.
And you have questions at this point? Things make sense, sort of. It's kind of a lot. So did you talk about the who is on these IP addresses?
No, I haven't gotten very deep into the packet. So back to Surya's website. So if we look, if we click on a row of this table, we can actually look at, there are a couple different views. There's the summary view, where you see the type of, if it was a request or a response packet, and then you get sort of more detailed as you go. So you can see some of the headers here. There's a cookie. I think this _GA, that's a Google cookie, I think.
Google Analytics.
Google, yep.
Tracking.
Yeah, I think I say it somewhere.
So this is interesting. When we click on this packet type that's text/HTML, we can actually see the body of the website sort of coming in this packet. Or that looks like a 301.
So one of the things you'll see through Herbivore, which you won't see through a browser, is all the redirects that happen. So my website is actually hosted on GitHub, but I forward the suryamattu.com domain from one place to another place. So when you actually hit suryamattu.com, it goes to one place. That place says, nope, not here. It's moved permanently to this other place. So now you go here. And you can see that actually play out in the network traffic.
Yeah, and it looks like, there's this thing here, this GitHub request ID, which is probably, connected,
Yeah, so that actually means that when your browser goes to my website, the page says, oh, this is not over here, but we're going to send you to this other website, and here's some information you need to give that website so that they give you the relevant page. So GitHub somewhere uses that ID to pull out my repository with my application on it.
Where does it say your host
Where does it say what?
You.
So you can see it says like location, suryamattu.com,
Right.
and then it says the GitHub request ID. So this is going, so this, the server here is GitHub, right? So this is GitHub responding to me saying, hey, that thing you want is actually at this other place. 301 means my computer will know to then send a request to the next place, and it'll go with this ID on it. Does that make sense?
So yeah, it can just be interesting to sort of look through all of these things, look through some of the headers. Sometimes when you get cookies, it's interesting to sort of look up different cookie IDs, and you can see how different companies are tracking you across, you know, could be just a session, you know, they just want to know if you're logged in or not logged in, or tracking you across other websites.
Show user agent.
What's that?
User agent.
Oh, that's a Fastly request ID. Isn't that an ad network?
Yep.
Yeah.
So that's only going from.
Oh, user agent. Okay, yeah. So I'm actually not totally clear on what user agent is.
So user agents are actually an interesting. So this is like one of the messages that will get sent in a packet, and it's this. It really starts like reflecting how these networks are sort of built on trust. Where basically user agent is my computer or my device telling a server that, hey, I want you to send me your website, but I am on this type of device. So let's say you are like a newspaper and you have like a mobile version and you have a desktop version. The way they know, the first way they know to like test that is by you telling them that, hey, I'm on a Mozilla, Intel, Mac OS, blah, blah, blah. But if I was doing this from my phone, it would say iPhone, iOS, something. And basically that server, once it sees that information, it's like, okay, if it's iOS, I'm going to send it this type of page. If it's OS X, I'm going to send it this type of page. One of the things you can do very easily is spoof that and then fool your computer into sending, spool that server into sending a different site. Like for example, a really easy trick to show this is if you go to any website, like let's say I go to the New York Times, and then I open the inspector, I can click this button, and now it will look like it should for I think for an iPhone. So I can make it look like an iPhone 5. And when I'm doing that, all that's actually happening is that user agent string is being changed to an iPhone. So again, going back to like how these systems are built on trust, and by us kind of self-identifying as something is where a lot of the vulnerability also comes in. Any questions? Yeah.
So if you have, so we're mostly looking at, from what I can tell, like a browser type traffic. So if you had like an email client, like actually that you're using on your desktop, what kind of, I guess I was first thinking of this because some of those things also have like, you know, images coming through and stuff like that, but then they also have just like the content, you know, like I write an email to my friend or whatever. I'm just curious, like what generally we would see like in terms of specificity of those things on here. Would we see like my computer says hello to whatever my email, you know, company, or like let's say I have like a school email or something like that, it's like it says hello to that school, and then that's like the level of specificity, or what is?
So that's a really good question, and it highlights one of the kind of limitations of Herbivore right now.
Okay.
Which is, so if you look at the ports, which are these numbers over here, you'll see there's always either a 443 or an 80 attached to it.
Okay.
And that's because currently we're only looking at HTTP and HTTPS traffic.
Okay.
So if you were doing stuff from your email server, it's either going to be like SMTP or POP3 or one of those things. And currently we're not looking at that stuff because we're trying to reduce the amount of things we're seeing. But you basically see an equivalent to what we were showing you, but written for that protocol.
Okay.
So everything we're showing you right now is basically what the HTTP protocol is spec. So you just open a package here. So like if you look at these headers of like content type, so we do another one which has more stuff. Yeah. So all of this stuff, these things are designed for the HTTP protocol.
Okay.
So for the SMTP protocol, there'll be equivalent stuff. It'll just be slightly different. So again, it's about this legibility. And what I do often is, like, it's hard to know like every single protocol. But if you just have this like kind of model in your head that each packet is going to have a bunch of different fields, and I just have to look up those fields for that protocol, you'll be able to infer what that line is telling you.
But would it be like at the level of a chunk of emails that come in at a
it
given
would
time,
be.
not at an individual email level, or like?
It would be depending on the size of the email, it might even be one email is split up over many packets.
Okay, yeah.
But hopefully it's encrypted, and so
and you can't
no
see
one's
it,
actually and just quickly, this port conversation and protocol conversation. So Surya said that we're looking at ports 80 and 443, but there are a ton of different ports. And these are ways that, so here's SMTP.
Yep. So if there was 25, so it says port 25 SMTP, that's what mail would go over.
Okay.
So if Herbivore was listening for 25, it would just come up in that thing. But right now we're like, oh, it's not for us, we're ignoring it.
Oh, I see.
Yeah. But with a tool like Wireshark, you could look specifically on that port or for that protocol, and we're just removing a lot of that complexity. But some of these are actually kind of funny. Like there are a lot of video games have like specific ports. So like Halo.
There's a word of the day port.
Oh, quote of the, is it quote of the day? Yeah.
Really early, it was really early, so it's port 17.
Yeah.
So if you see a message going on port 17, is likely going to be a quote of the day.
You want to inspect that packet.
Should we do the forms?
Yes, okay. So another sort of context that this project came out of was after this election in November, there were a lot of like digital security trainings happening, and it was, when you're talking about encryption, that can be it's like, that's just a word. What does that even mean? Yeah, what's up?
Well, there's this festival called Internet Yamichi. It's to turn everything from internet to physical objects. So this 1 year, me and Zach did this project called encrypted packets. So we make dumplings.
Yes, that is awesome. Oh my god, all the computers. So as we were interested in sort of having a way to explain the difference between HTTP and HTTPS, and looking at packets is a really helpful way to do that, because you can see that when, let's see if I can do both of these things at once.
Clear the packets.
Right, yeah, okay. When you look at a form that's submitted over HTTP, which means it's not encrypted, which is what we're gonna do. Okay, we'll do like jen@jen.com.
No .gen.
What?
No .gen available.
Oh yeah, we should change that. Secrets. Okay, so I'm gonna clear these so that we can actually sniff the form that is submitted and not have to deal with all that other stuff. I'm not gonna save it. Yeah. So if you submit a form over HTTP, you can actually see
The zoom.
Yeah.
Right, so you can see all that information being sent in plain text. So when you see HTTP, it's actually like a postcard, not a sealed envelope. That's the analogy they use, and this is what it literally means.
Yeah.
Does that make sense?
Sorry, missing. Was that the actual password you typed?
Yeah. Yeah, so then from there, it was much easier to be like, this is why you should get that browser extension, HTTPS everywhere, so that, you know, you're encrypting more of your traffic. Whereas you can have sort of vague conversations about encryption, but when you can actually look at the packets, it becomes much more like concrete, and then, you know, people look for this, you know, is it secure? Does it have a little lock? Is it HTTP or HTTPS?
What is that website that you were on before? That was
The forms. Yeah, we'll talk about this later. This is actually a glitch website. Glitch.com is a really cool site that we'll talk about at the end. But this is what that same process would look like with an encrypted form. Close that. And so you can see the post being made from this computer to this destination IP, but you can't actually see the content inside. It's encrypted.
So there's a lot more to it, obviously, but that's just like a baseline sort of thing about why people talk about HTTP and HTTPS. Is because if it's HTTP, it's just there to be grabbed, and every computer that is going between you and the server is seeing that information. So if like if your ISP is like logging traffic just for like server analytics, and you're sending an HTTP form, they actually have your password in there somewhere.
Yeah, and we demoed this a couple weeks ago, and someone went to the website of their blog to like log into their blog, and it was HTTP, and we were like,
yeah, it was the WordPress blog, and it was HTTP, and we could see their password being typed in to their system.
Yeah. So, yeah. You want to talk about ARP?
Yeah. So, so this is like the view that we've been talking about so far, is kind of thinking about the traffic that's going between your phone, your computer, and the network, right? So it's kind of like looking at this device going up and down. What Herbivore also lets you do is it lets you pay attention to your own local network. So here I'm going to try something. Hopefully it'll work. But I'm going to basically target my phone instead of my computer and see the packets going through that. So let's say I click on this and I do that. Sometimes it freaks out when there are many devices on the network, so I might have to restart it. So if I do that in a second. Let's try it again. So let's close this and start it again. This is also much easier to do when you're on your home network because it's a much more chill environment than this zone.
All yelling at you.
Yeah, I know, like everyone like staring. But here, let's try it again. Yeah, okay. So where this gets fun is you can start playing this like guess the app game. So I'm going to open an app on my phone, and I want you guys to try to determine which app I've opened. Right? So let's see if this works. Whoa, that's really weird. Okay, so let's not do that one. Let's try another one.
What was that?
Just a quick question before you go on. How did you know that was your phone?
Because I knew the MAC address of my phone, because I know it by heart. As I said, you will do if you do this stuff for long enough.
How come I can't see your phone in my Herbivore if I type in?
Because sometimes, like with these big networks, the subnets get weird, and it might just not have pinged at the right time. But it should come up eventually. So, can you guess what I opened?
Facebook.
Yep. Let's see, this one works. It's a bit slow.
Twitter.
Yep. Let's try another one.
Oh, I see Snapchat.
All right, okay. That was,
Slack.
yeah. What about this one?
iTunes?
Nope.
Pod?
It's a lot of stuff. It's like 54 packets.
New York Times.
Nope.
Browser.
No, this is my static image of the New York subway map app that I use. Right? So when we talk about ad trackers and all of that type of stuff, this is what it looks like on the network level. Right? So
It's
this.
still coming.
So it's an app.
No, I mean it's an app, but it has ads on it. Right? So what I use this thing for is just like looking at the subway map.
Why don't you just download the feed?
Well, I have now, but I use it as an example for this thing because it's a good. I won't get the whoa with like a different application. But again, the idea being that you should be able to investigate and look into your own devices and what's happening. So like you were saying about email earlier, this doesn't let you see email, but it can let you look at all the network devices in your local network, right? And then kind of investigate what's happening through that. So like another fun thing that I found recently was with this guy. With Snapchat, sometimes they actually send data over HTTP. Right? So like till recently, Instagram loaded all their images over HTTP. So when we first started Herbivore, you could see, even though the kind of your credentials and everything was over HTTPS, the actual image URL was HTTP. So we could pull out images that people were seeing on Instagram just by like running Herbivore. And this actually leads to the point that do not do this outside of your local network. This is very much would be considered illegal and in violation of the of the law, yes, that thing. But again, there's like a tension there because these are tools that we should be able to use. Kind of back to your point yesterday, to investigate this stuff and like kind of be able to think about it more deeply. But you have to do it with consideration. Like it's because it's not that powerful actually. Like if you think you can go and like fuck with shit with these tools, you really can't. The systems that you're kind of up against are way more sophisticated, but they do lead to an awareness and like a side channel attack that at least helps you inform your own decision making process in a way that you couldn't do before. So I don't see it anymore, but Snapchat had one of the interesting things you see over time is you can start like getting an intuition for what your device is doing. So I didn't know this, but when you actually open, let's see if this is going to work or not. When I open settings on my iPhone, I often see requests being sent. Let's see if that actually. I guess it doesn't do it. Maybe iOS 11 doesn't do it. I just upgraded. But yeah, you can basically start doing this thing, right? Where you're like kind of going through your phone and you're seeing what's happening on it, and you can start like investigating what is actually going through it. And also, like if a lot of people are running this right now at the same time, that's going to totally mess up the network. So yeah, I opened Twitter again, but let's see where's
Sounds like Uber or Lyft.
so Uber and Lyft, yeah, we can do those. That's a good one. Let's see.
So
I don't have Uber. I'll get Juno.
if I'm sniffing the computer that you guys are using,
Yeah.
and I'm seeing all these packets from your phone because you're sniffing them on that computer.
Yeah, that gets really loopy.
Okay.
Yeah, but yes.
Yeah,
I mean, if you guys want to see what's actually happening under the hood, I can show you this gross thing again. And we're going to, so what we're actually doing to do this whole thing is called a man in the middle, or as we like to say, person in the middle attack. And basically, yeah, I'll just show you really quickly. It's really simple. Zoom out of this. This is actually all you need to know, right? So ARP is a packet that basically tells you on a local network which MAC address, which we've talked about as your like social security number, is tied to which IP address. So it's a way for like the network to know that like this device is registered on this IP. And ARP is the protocol that lets you do this, and it's super insecure, there's no verifiability. So the way I'm actually doing this right now by intercepting devices is just sending these packets arbitrarily on the network saying, hey, I'm at this IP address, send me the traffic. So if you look at this line, where it says 192.168.1.36 is at blah blah blah. That's the MAC address of my computer. This is the IP address of my phone. So Herbivore created a packet that says, fuck the truth. This IP address is at this MAC address, and it's sending that to the router. So it's actually sending that packet to the router saying, hey, just so you know, this IP address 192.168.1.36 is at this MAC address. And simultaneously, it's telling my phone that the router's IP address 192.168.1.1, which is like a default IP for routers, is at the same MAC address. Oh, over here, you can see it over here. So you see how it's saying there's like a duplicate detected? Because Wireshark can tell that something's up. You're basically saying there's two things on the same IP address, but most routers don't bother checking. And if you do that, you can actually like intercept all this traffic. So this is again, it's going back to trying to think about these systems not in this context of hacking, but how inherently for network systems there is a direct relationship to vulnerability, because it has to be built on some level of trust or some protocol of understanding, where if you try to fuck with it, you're going to mess up the system. Does that make sense? I know that's kind of like in the weeds, but just to give you guys context, so don't do this on planes, don't do this in public places, because you will get into trouble. I think. But you have stories about that.
Yeah, that was before I knew about that disclaimer.
Yeah. So Jen has spent a lot of time. I mean, I've also spent a little bit of time like doing it in public, but you should just know that this is not something that you should do. Yeah.
So everything I've tried so far, you have to be connected to the network that you're trying to look at.
Yes.
But I imagine that, like in the real world, there are other places where you can intercept the HTTP traffic. So what are those places?
So it'll always be tied to like a wired or Wi-Fi network, because like for example, I can't do this on a cell phone, because a cell phone talking to a cell tower will definitely put me in jail if I try to do the same sort of system. Like you just can't do it. And that's why, like going back to the original of the cards you were showing, it's trying to like understand where we're sitting on this system. And Herbivore and this investigation is always within your own local contained space. Because when you kind of go out into the real world, you don't know what hardware is running on the other side, right? And what devices they're logging. So like that thing that I showed you in Wireshark, if you were doing this at like a US government agency, they would have this recorded. And they would know that this MAC address was kind of lying and saying like, and doing this attack. So there are ways around it, but like it's usually not really worth it to kind of go beyond that.
So the router knows sniffing.
Right, because you're telling the router, right? So I'm telling the router that like I'm telling it my MAC address. I could spoof it, but let's say I'm not, and like I'm telling it my MAC address and saying send me the traffic from these devices to me.
So the sniffing is actually lying about like, hey, I'm all of the computers, send me everything.
Yeah. I mean, no, not all of the computers, just the computer you're targeting, yeah.
But you could say I'm on computers. You could spoof everyone.
You could, yeah. But I think like if you do that, you're more likely to get caught, because you're going to like be sending around like stuff on the network, yeah.
But why it doesn't need to tell it is the computer, it just needs to listen. So why it says something to the router about it?
Because, so that used to be the case, and that's actually, so there used to be a tool called Carnivore, which is what Herbivore is kind of inspired by, which was made, that comes from a program called Omnivore, which was an FBI packet sniffing program in the 90s. But Carnivore used to do that. So there used to be this mode called promiscuous mode, where you could basically tell the router that every packet that's coming to you, just send it back out. But the way these systems are designed, that if a packet comes over, is in the ether, that's not designed for my MAC address, my computer is not going to listen to it. And routers now are smart about not letting other devices see traffic from those devices. Does that make sense?
Yes, but
it doesn't answer your question.
Like it's a Wi-Fi broadcast, so I can just listen to everything sent to everyone.
But you can't. But you'll only
to send anything. Why cannot be like totally passive and just listen?
Because at that level you'll only see the MAC addresses. You won't be able to decode the packet because it'll be encrypted by the Wi-Fi standard. So if you're on a Wi-Fi open network, then yes. If you're a Wi-Fi open network and someone's looking at an HTTP packet, you can totally.
Encrypted by the MAC address, or
Well, you only get the MAC address in that situation, but you don't get the URL that it's going to. So it's kind of less interesting. So does that make sense? We can talk about it later, but I understand your question, and there's a reason why you can't do it in that way. Yeah.
But so then, sorry, at this point I am getting a bit confused. But so then in a place like a public library system that has an IT department and has a commitment to the clientele, like it's an open unsecured network, but it has a commitment to the clientele being safe. I mean, can I presume that in our IT department, people are sort of looking to see like, oh, there's somebody on the network?
No, you can do it. No one will know. Like usually, I've done this in like places where I'm surprised that they did stop me, because no one's like looking all the time. So it might be there in the logs, but there's so many logs that unless you're looking at the time it's happening, it's unlikely. What they'll probably think is that something like glitched. I've run this at NYU. I've once run this at the Intercept, and like I was really surprised it worked over there. But it does, because again, the fun, like we talk about HTTP and HTTPS a lot, but ARP is terrible. ARP is like this protocol that's like 50 years old or something, and like there's no way to verify it. So there's some like kind of baseline stuff that you can't like get around in these systems. Any other?
So you said that the Intercept and places. What have you ever tried with the Link NYC?
Have you done that?
No, I did in the subway. The subways here have open Wi-Fi, and that can be interesting, but Link NYC I'm curious about.
Yeah, I haven't done it yet. I've done a lot of Wi-Fi sniffing around that stuff, but I haven't like looked at the network level yet. But you should do it now.
Yeah.
but you probably won't be able to do it because those networks tend to be these like virtual networks where you're the only device you see on your. It's a little more complicated, and usually like captive portal systems don't make it that easy to do this stuff.
Wait, would you get arrested for sniffing the Wi-Fi and the trains?
Depends on who you piss off. You could.
Yeah.
But it depends on if they want to target you or not.
Probably also depends on what you look like.
Well, yeah.
I'm guessing.
Yeah. Yes.
Yeah, we don't look correct for Wi-Fi sniffing on public.
Put on your Wi-Fi sniffing outfit.
Right, exactly.
Yeah, and bring your student ID.
Yeah, wear like your school shirt.
Yeah, right. I actually wear a suit. I look like a businessman. it's
Is that why you're wearing suits?
Right. Investment banker, that's my like.
You can always just use a throwaway device though, right? Like get a shitty laptop, do the sniffing, and then just throw it in the garbage when you leave.
No, you can also spoof the MAC address on your device, but I just find like it just depends. It's like more of like a karma question for me. Like if I'm putting it into the universe and I'm not trying to fuck with this shit, then no one will fuck with me back. Because like I just like don't trust any of this. And yeah, I guess like we just, that's pretty much it. If there are any more questions or you guys have more thoughts, we're happy to like yeah.
Oh, yeah. Well, okay. So, is there any way to get this data out of the
soon? Yeah.
Into another
soon. Okay. Yeah, it's coming. We just haven't done it yet. And this is a good time, I think, to go into why we're so slow on this and what's coming up next. So you want to talk about?
Yeah, we've been working on this together slowly for, a year or so through jobs and a thesis and lots of stuff. But we, now we have this stable tool. Stable tool. And we're sort of imagining like, okay, where does this live? It's not just going to live in GitHub and we'll just hand out cards with the GitHub address on it. And we're sort of envisioning this as possibly a larger network literacy kind of project. So maybe this would be one tool that lives with some of the activities like the ones that we did today on a website.
That one.
Yeah, but like less janky than this And this is sort of where Glitch comes in. Glitch is a really cool platform that whatever.
We use it.
Okay. Glitch is a really cool platform where it sort of gives you all the stuff you need to make a web project, make a project that lives on the internet. And so you can, if I just click like start a new project, create a website, it gives me, all of this basic stuff that I would need. I have like a live web page. It's really easy for other people to sort of make these sort of sketches on Glitch. And so we could like ask other people to come up with networking activities, and we could like link to them on this website. And it's all open source, which is something that we are both,
Is Surya's website used? Did
you make it? It should.
Yeah, you can fork it. No.
But yeah, so all of this kind of lives under an umbrella of what we're kind of calling invisible transmissions. And the idea is to basically have like a one-stop resource where you have a bunch of different modules that teach you about networking and technology, but always at this like sort of intersection of like technology, critical thinking, and like art or whatever your creative exploration is. And yeah, we just want to like put it out there that people are interested in making some sort of explanatory thing or like just like a project that kind of like can reveal stuff or talk about stuff in a fun way, where we're looking for people who want to kind of collaborate on this stuff, and like we're going to host all of it soon in one place. Yeah. Yeah, so I mean that's kind of what we have. You guys have any more questions? Cool. So I guess the last thing I'll show you then is a fun place where you can do Wi-Fi sniffing. Yeah, sure. Which is where I did Wi-Fi sniffing last year, or this year actually. Where you can basically use all these tricks and then go to all these places with a little antenna on a boat and like pick up all this information, right? So like just by actually sniffing Wi-Fi outside without doing anything illegal, I wasn't transmitting any packets, I was just picking up Wi-Fi traffic through all of Trump's like hotels. I found that they have one admin page on their local network that is an HTTP encrypted page, so it's basically not encrypted, and it was to the Mar-a-Lago database, which means that if someone was using Herbivore on that network, they could see the username and password the way we showed you for that device.
The list of names that they don't release.
Yeah, like the customer, they said that it obviously is not that, and they haven't shut it down yet. But we looked at the company that made it, and the service they provide is hotel hosting and database management for customer services and like scheduling and members list and all of this stuff.
Credit cards and stuff?
Yeah, so actually when we did the story, we found out that Eric Schneiderman in the DEA's office has sued the Trump hotels in the past because for a lot of credit card fraud 2 years ago, they noticed that the last valid transaction was at Trump hotels. And basically the Trump hotels like totally ignored them and said, we don't give a shit. So they had to sue them because 16,000 people's credit card information was picked up from Trump hotel Wi-Fi. Just like this, like just the way we're talking about, right? It's like someone's like listening on the network opportunistically and waiting to get something. So there's actually a lot of power in this stuff if you start like kind of thinking about where it lies.
What was the hat you were wearing?
Huh?
What was the hat you were wearing?
It was just a hat I bought. I hadn't even taken out if you look there's the cardboard is still in because I didn't realize it was like, so like hurting my head, but I was like, maybe it's just hot. You had a question?
Yeah, I was wondering if you have to like physically be there to get access to Wi-Fi, or if you can do it like.
Yes, you do have to physically be there. There are other styles of attack and thinking that let you attack things remotely. That's where like a lot of the botnet stuff kind of comes in. But a lot of this stuff is actually meant to be. And really, Herbivore is designed more to really not think about it as a hacking tool, but like to investigate your own space, right? Like you could kill someone with a hammer, but you're not hopefully going to, but you need a hammer for some other things also. Is kind of how I think about it.
But you can do it with an antenna, like, and depending on how powerful your antenna is.
Yeah, but you need to be, like, you can't do it from like India.
Right. But you could do it from miles away.
Yeah, that's what this was. That's why we were on a boat, because it was the only place I could get like line of sight for long enough to collect information from the network. Actually, more than the boat, this was what's really funny. We were at the Bedminster golf course and we were like driving up a dirt road to kind of get close to pick up the networks, and we just went through this, and the next thing you know, we were on the golf course, and I was like sitting there with my antenna like pointed at the building, and a bunch of white dudes in golf carts like driving around us, and we're like yeah, we're fine, we're just like going through New Jersey. Yeah, and we could collect all that information because it was like a dirt road, and we thought we were trespassing, but we were not. It was actually, you're allowed to go through that space.
So what's the, if I broadcast something in a newspaper or in a website, or if I shout it out the window, like where's the line from like me making information public and this network is broadcasting information that is available to anyone to see if they wanted to? So is that like a violation of privacy if I read someone's password from an unprotected network?
I mean, it depends on the context, right? So the reason any of this, the stuff we were showing, there was nothing that terrible about what Trump's infrastructure was doing. But when you compare it to these things, so there's this department called the Department of Intelligence Systems Analysis or whatever. It's like one of the government agencies that's entire job is to tell you what the like standard for different levels of security clearance your technology infrastructure has to have. So they have this thing called STIGs, which are security technical implementation guides. And you see the amount of money the US government spends on Wi-Fi security. It's like for Camp David, they spent like $60 million in like 2 years to secure it, because then they're talking about that level of security, right? Where it's like you got to make sure there's nothing available, because you have to always think about the threat. So who's going to attack you? If you're worried about like state actors, then you're going to have to do that type of thing. But if your home network, like it's normally kind of fine.
Like, so if I go to a Starbucks and I'm like sniffing everyone on the Wi-Fi and I catch someone's like pictures or text or whatever, what's the difference between me doing that from a computer and me overhearing a conversation from the
Yeah, totally. And like, I mean, that part's fine, right?
Google Street View.
Yeah, that's a good example.
Yeah.
What's the example?
There was this case where Google Street View, they were sniffing up all of the Wi-Fi traffic on open networks, and they were like, it's public. I mean, it's not secured, so it's basically ours, right? Kind of.
But that's where like it gets more interesting, because the model of you overhearing that conversation is what companies like Google do or say, but the reality is Google is overhearing every conversation.
Right.
And it's different to when you're doing it sitting in a coffee shop and listening, but then when they are doing it to everyone, because that data set is very different to your data set. But the reality is that you're more likely to get penalized for doing it than they are. Right? And that's where this kind of tension lies, and that's why we talk about these like encrypted systems. It's not because what you're hiding is something that's super precious to you, but it's like it's like data labor, right? Like giving these companies the access to this information or the ability to build kind of machine learning driven or whatever predictive models using all of our shit eventually kind of skews the power structure in their favor.
And I would just say that it can be really hard to just jump into this conversation, and that this is another reason why like I love packets and talking about packet sniffing, because it can be an access point to be like, let's talk about the privacy implications and let's talk about different scales, and but if you just want to talk to privacy folks or activists or something about it's really hard to find an entry point, and so this can be helpful for that. And I would love to like for tools like this and other tools to be able to open up those conversations.
Yeah, I think the best way to kind of defend ourselves is not waiting for the legislator or, government passing law, is to actively building tools to kind of help us. Because the laws and the legislation and kind of protection will never catch up with the rate technology grows every day.
So when you go to a coffee shop and like it's open and you can see all that stuff, are you like to the barista, like, hey, the network's open, or I don't know, like, do you have these
I don't talk to anyone.
like great gray hat moments, I guess, or I don't know.
It's a good question. I mean, it's probably not. It depends on the coffee shop. If it's at Starbucks, definitely not, because it's all Google run. But if it's like at a local coffee shop where I like the person and I care about them, I would probably be more likely to do it. But yeah, I mean that's the thing, right? Like, there's none of this stuff is like, there's no like kind of binary right and wrong. It's all on a spectrum depending on the context you operate in. Yeah, and your intention.
So I had this conversation with some DeFi folks, and I might be also remembering this wrong, but like, because in terms of legalities and stuff you were asking before, so the law that a lot of this kind of falls under, the area laws, Computer Fraud and Abuse Act, and it's a pretty broad, general sort of coverage. And they were saying one of the distinctions oftentimes with network stuff is, or like the summarized thing is like, if you don't own the network, like if you didn't buy the router, you don't pay for the service, and you didn't hook it up yourself, then if you're doing something that whoever does own the network doesn't like, they can use this really broad law, Computer Fraud and Abuse Act, to go after you.
Yep, and that's a real problem, right?
Yeah, and then in terms of like, what are the consequences? Like so much that has to do with the law. It's like, well, how good are their lawyers? How good are they at using this Computer Fraud and Abuse Act? And if the answer is very good, then even just sniffing around and stuff.
I mean, that even goes to the kind of stuff you were showing us today could be considered illegal across. Like, I mean, web scraping can be considered illegal. It's like a journalist or data journalist, like bread and butter. It's technically illegal under the CFAA if you argue the case well.
And some folks have.
Yep.
Yeah.
Yep. And yeah. Good question.
Just a practice question. So if somebody on the Wi-Fi was using a VPN, would I be able to see just the domains that they were browsing?
So good question. So with VPNs work on port 20 and 21, I think, usually, so you wouldn't see any of the traffic on Herbivore right now. Because it tunnels it through a different kind of channel. But over time, we'd be able to add those sorts of features in to show you which one is a VPN packet or this. So like it's all of the stuff is again going out, and we are currently only listening to 80 and 443, because if you don't, then you kind of get into this zone where like there's just like constant like stuff happening, and it gets overwhelming.
Okay, but if you were, would it be just on the domain level?
You wouldn't even get the domain. Okay. You would just see that there's traffic, and you see the IP address it's going to.
Can you save any of this right now that you've sniffed on Herbivore, or no?
I don't think so.
Copy and paste.
Screenshot.
Yeah.
I mean, I could do
right.
like a. Let's see. Again. Oh yeah. My packets. There are only like 18 packets right now.
Oh, but it's like a browser based.
It's like a JSON file which I can export. I just haven't made the button yet. Yeah, to put it out. So I'm going to put it into this net JSON format, which I haven't done yet, which is yeah, there's like there'll be a
RPG maker. So if you are a data journalist and your bread and butter is, why don't you like spoof your MAC address constantly?
I do.
You do?
Yeah, all the time.
How do they catch you if you're spoofing your MAC address?
You don't.
Okay.
But if they're looking for you, they can like see video footage and see when you came in and see when a new device came on the network, and like, but they can fingerprint you in other ways. Your MAC address is just one way, but if you really want to get into the weeds of it, you can see like latency time to kind of figure out what your network processor is, and like there's like a bunch of different things. I mean, it's just like it depends on who your adversary is, right? But for me, what's more interesting about it is like how do you kind of bring up these conversations to highlight the political aspects of them. So it's like how, like, because I think you need like a level of technical literacy to have a nuanced conversation about where the actual challenges in these systems are. Because there is stuff that like big infrastructure gives us, like HTTPS is something that like GitHub hosting servers is great because it means you're getting that by default, which is a pain in the ass to implement, but that has a trade-off in another aspect. So it's like, but we can't have those conversations if it becomes like, oh, this is a privacy issue. And then someone will be like, I have nothing to hide. And then you're like, shoot me now. Because like, this is like a pointless conversation. Right? So it's like, so like that's the thing. Like, how do we kind of have these nuanced conversations but with more like compelling evidence than just like, trust me, it's bad.
Right.
Which is kind of where everything lands, I think, these days.
Yeah.
And that stuff.
Like instead of, like when you're first meeting someone, instead of getting their name, you just already sniffed all their packets. You know, and then you're like, oh, I see you're like looking at blah, blah, blah.
I've actually met people. I met someone and I was sniffing their Wi-Fi packets and I was like talking to them. And they're like, oh man, yeah, have you been, so I was talking to them, oh, so you work at that university, right? They're like, yeah, because I saw the university thing. And their phone's name was their name. And they had obviously tethered their phone to their laptop, so I got their name as a Wi-Fi network.
Wow.
Then I was like, but then really, so like I had this conversation, figured out who they were, talking about their packets, and then I actually knew they stayed at a hotel in Japan. And I was like, how was that stay at that hotel? And they're like, what? That's actually how I got my job at ProPublica. I sniffed Dana Boyd's packets.
Wi-Fi whisper thing, right?
What's up?
Like the Wi-Fi whisper.
Yeah, so that kind of stuff, right? So yeah, there are other tools too. I mean, I built another tool a while back, which is way cruder than Herbivore, called NSHey. And this lets you sniff Wi-Fi packets. I can show you what it looks like. Yeah, exactly. Where are my releases? There. So it's like a really crude GUI. It just looks like that, and all it does is it puts your Wi-Fi, it's kind of, we won't have the details. It basically puts your Wi-Fi card into monitor mode and just lets you pick up everything at the Wi-Fi level. So not at the network level, like not at like RADNets, but literally any Wi-Fi packets that are just like floating around in space, which is kind of back to what you were talking about earlier, right? Cool. Any other questions, thoughts, feelings?
Yeah, we have design feedback.
Yeah, great. Yeah, that's fine. I expect that. Thanks very much for coming.